All right, good morning, everybody. My name is David Zhou. I'm the co-lead of Blockchain USC's governance team. It's my honor to introduce Neel Somani, our next speaker and a fellow alum of UC Berkeley. Neel is the founder and the CEO of Eclipse, a layer 2 solution aimed at enhancing Ethereum through the Solana virtual machine's capabilities. Remarkably, Eclipse has recently secured a 50 million Series A funding, co-led by esteemed VCs such as Placeholders and HackVC. Neil's journey in tech began at Airbnb as a software engineer, where he developed a strong foundation in software development. He later transitioned into Citadel as a quant researcher, where he gained valuable experience in finance technologies. However, Neil decided, and I quote, to quit his cushy job at Citadel to get wrecked in Web3. Specifically, Neel is tackling the performance challenge of layer 1 solutions. With a rich background in computer science, Neel's approach to blockchain innovation is deeply influenced by his scholarly work, particularly in the realms of type systems and differential privacy. This unique blend of experience and expertise fuels his contributions to the blockchain space. Let's extend a warm welcome to Neel Somani.
Right. Is there a clicker for the slides?
Yeah, it should be up on the podium.
Okay. Hi guys. Okay, quick question. By a show of hands, who here is actively building in crypto? Okay, so maybe like half, maybe a third of the people. And then who is crypto curious? Okay, so the majority of people. All right, so these slides are totally for the wrong audience, but that's okay. I'll frame it a little bit differently. And what I'll do is I'll take a step back and I'll talk about what I think the biggest problems facing blockchain infrastructure right now. We'll talk about some meaningful way for you guys to think about it and frame it. We'll, of course, touch on what Eclipse is doing. And then I want to also touch on use cases because I think the last presentation was on a lot of use cases. Can also give Eclipse's perspective on what we think makes sense or what makes less sense. So you guys probably have heard the term layer 2 blockchain before versus layer 1. And what that really comes down to is how you get security for your blockchain. There's two types of security properties. There's safety, meaning I don't want bad things to happen. And there's liveness, meaning I want good things to keep happening. Where the biggest safety property is I don't want my chain to get reorganized. So once I send someone money, that should never be undone. And the second thing is liveness, meaning if I want to get a transaction in the blockchain, I should be able to do so. So layer 1 blockchain needs to do this security on its own. And ultimately, this can be converted to some number of dollars. Costs billions and billions of dollars to secure Ethereum, Bitcoin's even more. And then you have the long tail of blockchains like Solana and all the other chains. What layer 2 blockchains try to do is get those safety and liveness properties by leveraging what already exists, typically Ethereum. So Ethereum is built with the purpose of supporting layer 2 blockchains at this point. Now we have people building them on Bitcoin, but this is a different approach to building blockchains so that you don't have to bootstrap your own security. So that's the high level. Eclipse is a layer 2, and we're approaching it a little bit differently than most folks, where most people try to extend Ethereum one for one, and they say that any code written for Ethereum cannot run on a layer 2 blockchain. That's not what Eclipse did. And the reason for that is that Ethereum was never really built for performance. So like some of the other presenters have mentioned, if you look at the Ethereum base layer, it's very low throughput. And that's largely because the virtual machine, so the part that actually executes programs, executes them very slowly. It was not built for the purpose of parallelizing things and making it very low latency and high throughput. On the other hand, we have blockchains like Solana, which is a layer 1 blockchain, which you guys might have heard of. And these guys have been focusing solely on performance from day one. They've been around for a few years now, and contrary to what other blockchains might claim, Solana at this point has the most performant execution layer in crypto. There are other ways to scale. You can spin up additional blockchains, but Solana is one big, beefy blockchain. It's super performant, meaning it's high throughput, low latency, and they've been focusing on that. The downside is that they lost a lot of the verifiability that layer 2s require. So they fragmented security, and they're trying to bootstrap that security themselves. And that's the downside. The upside is that they have great performance. So what we're doing is we fork Solana, and we're building the most performant layer 2 blockchain. So this is intended to provide the same throughput as Solana, but then it also posts proofs, and I'll explain some of those details on how exactly we derive security from Ethereum. But that's essentially the idea. We'll be launching our mainnet relatively soon. So those are the two main parts there, Solana, Ethereum. Unless you're very crypto native, you likely have not heard of Celestia or Risk Zero. And frankly, they're not really that important to what Eclipse is doing. They are relevant features. They're needed in terms of how Eclipse is built right now. But the main idea is that we're building the most performant blockchain on, or most performant layer 2 on Ethereum. And those two things are in service of that fact. So we call the virtual machine this SVM, Solana Virtual Machine. We pick it versus the EVM, or the Ethereum Virtual Machine, for a few reasons. First is performance, which I've touched on a lot. The second is security, which is a different type of security than what I was referring to before. This is security in how you write your smart contracts and what types of exploits or vulnerabilities happen. So you guys might have heard of massive crypto hacks of hundreds of millions of dollars. There's a big class of attacks called reentrancy attacks, where if you write your smart contract in the wrong way, then it basically means that someone could, in some cases, exploit that and make your program behave in ways that you did not expect. So Solana attempts to remove reentrancy attacks, at least a large class of them. There's other things like ease of use and other things that are more crypto native and more important for the folks that are building on the blockchain, but those first 2 points are the most important ones. And the big piece here is that Solana, this is intelligible to even folks that are not in crypto, but the idea of being able to run multiple programs at the same time versus one program at a time is essentially what Solana innovated on. And they said, we're going to build a blockchain so that 100 programs could theoretically run every second, and we'd have 25 programs running at a time, as opposed to Ethereum, which orders every transaction in a straight line and executes them one at a time. So this sounds trivial to folks that are not in crypto, because parallelism is rampant in databases and traditional web servers. But for crypto, this was like the first parallelized layer 1. And now there's other blockchains that are doing this, like Aptos and Sui. But Solana's been working on this and perfecting it for years. So that's why we picked Solana. It's a little bit of a marketing term because any virtual machine, even the EVM, could theoretically be parallelized. But Solana's already been doing this. So that's the reason why we picked it. Okay, this is not as relevant to you guys. I do also want to touch on, like, this sounds like a little bit too good to be true, right? So we just slap parallelism onto Ethereum. Now we have the most performant layer 2. What's the downside? And if you guys have been using crypto in the last week or two, a lot of changes have been happening. The biggest change is that on Solana, we're actually experiencing congestion for one of the first times. And that's because there's a ton of activity happening. So a lot of meme coins being traded and other types of tokens. And as a result, Solana has proven itself to actually hit its limit for one of the first times in a long time. They had some issues a couple of years ago, and they fixed a lot of them. So that's one point. And then the second is that on the Ethereum side, they've made gas fees much lower. And what they did was they made it so that there's a way to I'm trying to phrase this in like the best way possible, but they reduced the base cost for a layer 2 to post a transaction to Ethereum. And that's a critical part of a layer 2 security model. So therefore, the cost went way down, but the cost is still expensive. And that cost is because the execution layer is not able to scale. So those are the two biggest changes that have happened in the last 2 weeks, namely that Solana has proven that it's not able to scale as a layer 1. And 2, on Ethereum layer 2s, they've proven that the execution layer is not suitable. So the second point is really favorable for Eclipse. The first point, not so much. I mean, we forked Solana. So we're not going to really exceed Solana's throughput in the short term. So we want to make sure that we can properly address those issues. And the reasons for that are a mix of economics, given that Solana is a novel virtual machine, and they have to build their own fee market and new economic model, which they're still perfecting. And then the second point is that Solana has some disadvantages that Eclipse doesn't have. And what I mean is that because Eclipse is generating proofs for all the transactions that we're running, and we're borrowing Ethereum security, it means we actually don't need that many people to run the Eclipse network. Whereas if you look at Avalanche or Solana or any other blockchain, you need thousands of nodes to run this. And that's part of the reason why it's harder to achieve a security as zero on layer 1. The other reason is that there's like literal dollars that need to be staked on the chain. But for Eclipse, we don't have to do that. And therefore, we can put all the costs toward building a really performant execution layer, and therefore support higher transaction volume than even Solana's layer 1 can support. So that's the end goal and what Eclipse is working towards. And what I basically would want to encourage builders to do is take a look at the layer 2 ecosystem, think about what are the advantages of layer 2s, and how can you really lean into that. You're going to end up with something very similar to what Eclipse looks like. And then I also want to chat a bit about why we're building this as an Ethereum layer 2 rather than as another layer 1. So like I was mentioning, there's some amount of dollars that you have to put down to secure any blockchain, whether it's Bitcoin, Ethereum, something else. So in our case, we just don't think it's realistic for us to ever be competitive with Ethereum in terms of the amount of economic stake that's being used to secure it. And for that reason, we want to build on Ethereum, because if you don't have a secure blockchain, then you're losing one of the biggest value propositions of crypto. There's probably like security, privacy, and composability. These are, in my view, the biggest advantages to being on chain. And if you're losing security, it means that transactions can be undone, and they're really subject to government attacks and things that, in general, crypto is designed to be built to protect against. So that's the reason to be on Ethereum. These are the ways that we, like, quote unquote, borrow security or get safety and liveness. I won't go into them because it gets a little bit technical. But those reasons why it matters is that now you can always get your transaction into Eclipse. You don't have to be concerned that transactions will get reordered. And you also get the performance that we're promising. And another point is that Ethereum just has the most money on it, meaning that there's the most users currently using Ethereum, and therefore we can ideally tap into those users, and they can use the applications that are being built on Eclipse. This is just some more objective comparison on throughput, cost, things like that. So this is essentially the pitch in one line. We're saying, let's take the best, most performant virtual machine, which is built for that purpose, and leverage the best internet money, which arguably is Bitcoin, but Bitcoin's not really built for layer 2s. So Ethereum is the next best. So these are things that sound extremely crypto native, and they probably don't mean anything to the folks that are crypto curious. And the reason why I list applications like this is mostly because I think that things like taking a traditional game and trying to put it on chain have been tried many times before, and in general are dead ends. That even applies to bringing traditional institutions on chain. When we talk about things like permission chains, it really doesn't make sense, because there's additional cost for running every single transaction, and you're incurring that cost for no reason. You might as well just run a database. One other way to think about it is that these institutions can also just wait until the regulation is more clearly defined and then move to a permissionless blockchain. There's just like no reason to have half of a blockchain, in my view. So for that reason, I'd rather lean into extremely crypto-native concepts. So things that either lean into speculation, which is one of the closest things that has a semblance to PMF in crypto, or somehow leverage things that are extremely crypto-native, like these are called liquid stake tokens or LRTs. These are assets that only exist in crypto, and they're ways of getting yield, basically. So you can put your money on chain, and you can generate 10 to 20%. Of course, there's some risk attached to that, and you have to put your money on chain. But things that leverage that yield in a unique way, I think are genuinely interesting. Okay, so on-chain FX trading, that's something that's more non-crypto native. I just think that FX has a lot of volume, and something like Eclipse could theoretically scale to accommodate it compared to existing blockchains. And things that mint like massive amounts of NFTs. Historically, if you're on Ethereum, if you mint anything more than a couple hundred NFTs, even like other blockchains, traditionally layer 1s cannot handle NFT mints very well. Solana, on the other hand, had massive NFT mints, and they were forced to build their blockchain around that, and therefore they can accommodate like literally millions of NFTs being minted. That's maybe not meaningful as like a concept at a high level, but this is as if you're a store or something. You're a secondhand used goods store, and you want to list all of your items on chain so that people can trade them freely. This is the only way that you can accommodate it. And then this last category is called DePINs, or decentralized physical infrastructure networks. So this is one category of crypto apps which you guys might be familiar with through Helium, or like Filecoin is an example of a DePIN. But it's folks that are taking physical things like the lights on the ceiling or something, and you can track the activity of those devices on chain. And then you can incentivize different types of activity. For example, maybe you want people to use power less. Then you might give them tokens in exchange for turning off their lights at certain times of the day. And this is nice because now you have this additional asset. You don't have to give people real dollars. And if you can drive cash flows to that asset, then theoretically it could grow into whatever price people are trading it at. So these are the high-level reasons why someone in crypto would build on Eclipse. It's that you get high performance, you get to benefit from Ethereum security and the user base there, and then we also provide many forms of ecosystem support. So if you're a college student interested in building a project in crypto, I encourage you to reach out. I'll be sticking around here after this panel or talk, and yeah, we can chat a bit more about how we can get you started in crypto. Okay, great. Happy to answer any questions. I know it was like a little more technical than some of the other presentations, but Yep.
I'm curious if you're looking to implement FireDancer into your fork of Solana.
Yeah, we will. I think it will benefit more from it than Solana L1 will, because Solana has to maintain client diversity. And in general, a blockchain's limited by its slowest client, whereas we can upgrade all of our nodes to FireDancer at once.
Interesting.
Yeah, FireDancer, for context, this is a new version of the Solana client, which is built from the ground up to be extremely performant. So this is something that Solana's been building for the last year or so. It's going to take another year, but once they reach that, then they will exceed the performance that they've already been achieving, which is best in class.
Hey Neil, thanks for coming. Briefly on this slide, could you elaborate more on the continuous prediction market, the use case? Yeah.
Yeah, on this. So this is one of my coworkers' ideas, so I can connect you with them. But my understanding of this idea is that, in general, prediction markets are like, yeah, that's a good question. I'm not sure exactly. I guess this would be like some kind of bet that's traded in real time. So you can constantly see, maybe like throughout a presidential debate, people can make smaller sized bets than what would ordinarily be enabled by using one of these typical political betting markets, something like that. And you can see in real time what the odds are.
Thank you.
Hi, I'm just curious, what were some of the biggest challenges you faced when you were developing Eclipse?
So initially, we actually were not building this version of Eclipse. We were building a version where each person would get their own blockchain. And it's very similar to what some of the other, like Avalanche is doing. Everyone gets their own layer 1 blockchain. For Eclipse, everyone would get their own layer 2 blockchain. And that was the original approach. And the thinking is that if the Solana virtual machine is the most performant virtual machine, then let's just give that to everyone. And then you can have your own chain, so you get all the benefits of having your own chain as well. But what we came to realize were that there were not really that many benefits of having your own blockchain. And in general, almost anything you can achieve on your own blockchain, you're better off being on a shared chain. And I can go into specific examples, but like types of gas customizations you can still achieve on a shared chain. Different types of apps where people think that the throughput exceeds what's possible actually are possible in Solana. They just haven't tried it. The cost can be cut really low. So in general, I basically just didn't, there wasn't enough demand for people to have their own chain. So we pivoted toward this one shared chain where we bear all the costs, but also we get the upside of if there is tremendous transaction volume, then we'd collect fees on each one.
Yeah, this is a less technical question, but I was just curious if you have any thoughts on what happens if Ethereum's like declared a security by the SEC, and would that have potentially affect Solana?
Yeah, that's a good question. So that would be declaring ETH, the asset, as a security, which technically doesn't really affect the operation of Ethereum itself. It does impact who can operate it, because now if you're operating an Ethereum validator, for example, you'd likely have to be much more compliant. It impacts who can use the blockchain, because now if you want to buy ETH in the US, then you would have to follow all the instructions required by whether it's Reg A, Reg D, whatever all the security stuff is. So yeah, it'd probably impact the usage of blockchain detrimentally if it were to be declared a security.
Yeah, quick question on some of these new use cases that are enabled. They also require liquidity, and we've seen that like fragmentation that happens on layer 2s as a whole. How do you think about attracting like liquidity and therefore like developers onto Eclipse?
So I think about it in two ways. One is that I normally think about the layer 1 blockchain landscape, and that's even more fragmented from a liquidity perspective. There's like a long tail of 1,000 layer 1 blockchains that no one talks about. In the layer 2 ecosystem, it's a little bit better because the way that we borrow security from Ethereum is we have some really good bridge contract on Ethereum. So that's a great conduit to attract liquidity through. Of course, you still have to incentivize it. But if you look at the projects on Ethereum right now, like Blast, EigenLayer, even Manta, a lot of them have attracted 9, 10 figures plus of TVL or of liquidity on their chain. And just I'm sure that everyone in the audience is aware of like the significance of liquidity, but for a lot of the protocols like AMMs, for example, so the ways that you exchange tokens in crypto, they require a lot of liquidity to be locked up or a lot of dollars to be locked up. So getting that money on your chain is essential to making sure that your chain is actually usable from like a slippage perspective. Like you don't want to lose too much money every time you make a trade because there aren't enough people to trade against. So, so yeah, we'll have some kinds of incentives around that. There's inorganic commitments that we gathered from market makers and other folks that participated in investing in Eclipse. And then the last piece is that we'll likely have to lean into new types of apps and incentives for people to try those out. So we'll be bridging them over from Ethereum in particular. And that's probably the biggest asset pool to think about. Bitcoin's also a great asset pool, but it's just a little bit more cumbersome to bridge from there. So we don't find that that's as worthwhile for us to incentivize.
Makes sense. Thank you.
Thanks, Neil. I actually have a question before we continue. So I was wondering, since you're building a layer 2, how do you sort of view the future of shared sequencing and atomic composability, and how does Eclipse with the SVM fit into that?
So I think shared sequencing as a concept is very interesting. And I've also angel invested in like a lot of shared sequencers. I do think that there's a lot of like research problems that are open in shared sequencing. So for the audience who's not familiar, so for every layer 2 blockchain, the first step is you have to order all of the transactions. That's done by a sequencer. And that's actually typically a point of centralization. And people point to it a lot of the time. They say, well, layer 2s are centralized because the sequencer is just one person operating it or a few entities. In actuality, you can achieve safety and liveness properties even with this centralized sequencer, but that's kind of aside the point. But anyway, the downside of having your own sequencer is that there's no interoperability between your blockchain and other blockchains. So a shared sequencer is one entity that's sequencing for both layer 2s A and B. So that might be Eclipse and Optimism. And when you have the same sequencer for both of those, then I could have a program that executes one part of it on Optimism and the other part on Eclipse. You get new types of composability. So that's important, and that's really important for EVM chains, given that there are so many of them. There's like hundreds of layer 2s at this point that are using the Ethereum virtual machine. And they have to spin up more of them because the Ethereum virtual machine is not able to scale at this point. From Eclipse's perspective, we don't really think that there need to be that many layer 2s to begin with. We think that most applications should basically be on the same layer 2, and we should just juice that layer 2 as much as possible to make it super parallelized, super expensive to run, and make the transactions really, so we bear this expensive cost of operating the chain, but running programs becomes very cheap, and they can all compose with each other there. So I generally prefer for people to all build, of course I'm going to say that, right, that I prefer for everyone to build on Eclipse. The difference between me saying that versus another layer 2 is that Eclipse can actually accommodate that, whereas other layer 2s can't. So, but at the same time, I do think that all the EVM chains probably should use a shared sequencer. I think it's probably the direction that Optimism is going to head in with their super chain and other EVM ecosystems. Like Arbitrum's partnered with Espresso, and I think people are seeing the necessity of it. I just also think that there's probably another 6 months or more of research that needs to be done to actually make that atomic composition between two chains enforceable. Because there's this weird hidden link, there's this missing link in the trust assumption that actually makes that trustless. So it's not, we can chat about it after the after this talk.
Thanks, Neel, for that. Any more questions, though? Okay, one more.
So you'd mentioned that you're getting ready for mainnet, and that's coming soon. What's the plans, I guess, on the timing for an airdrop for people to incentivize usage of the testnet and
So,
growing your volume
yeah.
on mainnet?
We haven't contemplated any concrete plans around the token at this point. So that's pretty much it, yeah.
All right, thank you, Neel.
All right, guys, I hope everybody enjoyed the first session with Tarun, John, and Neel. We're going to go ahead and enter into a networking break right now. We have some lunch on the right side here hosted by EduDAO. So make your way over there if you want some lunch. Outside, we have some small eats and a networking area. And we'll meet back here at 1:20 sharp to hear from Animoca Ventures, followed by Onyx, and then Polymer Labs. Thank you, everybody.